Hello dear students, welcome to Tejama YouTube channel. In this video, I'm going to derive three equations of motion from kinematics. They are V is equal to U plus AT, then V square is equal to U square plus 2AS, and X is equal to UT plus half AT square. For that, I'm going to make use of this velocity versus time graph. I have taken velocity along y-axis and time along x-axis. So here you can write some consideration like consider a particle moving with the uniform acceleration a with initial velocity u, and after some time its velocity is v. So where u is the initial velocity, u is the initial velocity at time t is equal to 0. What about v? V is the final velocity after some time t. So here the velocity is u at t is equal to 0 and velocity is v at t is equal to t. Let me consider this is the time taken to acquire the velocity v with acceleration a. Okay, I have drawn this dotted lines so that it will help me to find few things like slope and other things. Let me take this triangle, right angle triangle is a b c, where AB is making an angle theta with the horizontal here, that is AC. Okay. Now we know that the slope of velocity versus time graph gives what? Slope of velocity versus time graph gives acceleration, or is equal to acceleration. So let me find the slope. So acceleration A is equal to slope of the triangle ABC here, that is equal to tan theta. What is tan theta? Opposite by adjacent. Opposite is BC and adjacent is AC. So we know that from x-axis to C, the value is u because that gives you the initial velocity, and the same x-axis to B will give you final velocity. So then BC is given by V total velocity minus initial velocity, that is V minus U will give you BC value. Therefore, acceleration A is equal to V minus U divided by T. We can multiply this T to the left hand side. So that is AT is equal to V minus U. We can just rearrange the terms. We'll get V is equal to U plus AT. Just taking U to the left side. Okay. So that is about this. Now let us jump to the next equation of motion, that is v square is equal to u square plus 2s. Here also I'll consider this is a, b, c, this is d, this is e, initial velocity u. So where u is initial velocity, and v is final velocity. Okay, and a is acceleration. All those things you can write. Where let me consider d length is time t, dc length is u initial velocity, and bd length is v final velocity. Here I need to find the velocity square is equal to initial velocity square plus 2ax. For that, I'm going to use this. We know that area under velocity time graph gives what? Displacement, right? So let me use that here. Area under velocity time graph gives or is equal to displacement. So the displacement x is equal to area of this graph, that is area of the trapezium A B C D E. E A B C D E. Okay. So that gives you, what is the formula for area of the trapezium? Half into sum of parallel sides, that is AE plus BD into height, that is AC. So from that I can get x is equal to half. What is AE? A is parallel to CD, so U. What is BD, which is V? What is AC? AC is nothing but D, that is T. Okay, one thing is this. What is T here? Since we know that acceleration is equal to V minus U by T. From the previous derivation, we have A is equal to V minus U by T. So I'm going to take A is equal to V minus U by T and rearrange this. T is equal to V minus U by A. So if I substitute that here, x is equal to half into U plus V into V minus U by A. Okay, na? Then x is equal to U plus V into U, V plus U into V minus U is V square minus U square divided by 2A is there. Just rearrange the terms, you'll get V square minus U square is equal to 2AX. So V square is equal to U square plus 2AX. Okay, that is about this derivation. That is equation of motion V square is equal to U square plus 2AX using velocity versus time graph. You can add some theory for this if you want. Okay, then last one we have, that is x is equal to ut plus half at square using velocity time graph. So here let me consider this is A at initial velocity u, B, C, D, E. Here initial velocity is u, from C to D it is u, or D to C, and velocity is increasing. So final velocity after some time t is V. T I can write here. Okay, now how to find out this displacement? So where u is initial velocity, V is final velocity, you can write some consideration. Please add some consideration, like consider a particle moving with constant acceleration with initial velocity u. After time t, its velocity is V. From the velocity versus time graph. Okay, all those things you can write. After that, I'll write here, that is area under velocity versus time graph gives displacement. So the displacement x is given by area of velocity time graph, that is area of trapezium E A B C D. X is equal to area of this trapezium. I'll split into two parts. That is area of the triangle ABC plus area of rectangle EACD. I will do it separately for this one and this one I will add. So that I will get two parts, which is similar to previous case. Area of triangle is half into base. Base is AC into height is BC plus half into, sorry, area of rectangle length into breadth. So that rectangle is given by AE into ED into ED. Now x is equal to half into, what is AC is nothing but time t, BC is V minus U plus AE is U ED E to D T. Okay, so what is V minus U? From the first derivation, that is V is equal to U plus AT. V minus U is equal to AT. Half into T into V minus U is AT plus UT. So first I'll write UT plus half into A into T into T square, hence derived. This is the third equation of motion, that is x is equal to ut plus half at square. So these are the three equations of motion. If I write them together, we will get three equations. They are x is equal to ut plus half at square, v square is equal to u square plus 2ax, and last one is this and this one. Okay now. So that is about this video. If you want any other derivations to be done, please text me in the comment section. I will try to upload those videos as soon as possible. And if you feel that these videos are useful, please share it to your friends and make them subscribe. Thank you so much.